Quiz 4 key. Radical resonance, right? Radical resonance here. Again, the biggest thing to remember to think about is the right type of arrows, and when you're trying to make pi bonds, two electrons are coming together between two bonds. So this single-headed arrow, one electron goes to an atom, and then right again, it's just like carbocations. They gotta be next to a pi bond, so they can only do resonance with things with p orbitals, right? The radical's in a p orbital, so you can't do resonance up here, right? And it has to have a pi bond. And so there you go. You get those different radical resonances. Hopefully nothing too different than what you're used to. Let's see. Now we do PBr3. Okay. Yep, go ahead. For 2, give the mechanism the product of the reaction. So what do we need to recognize? Alcohol, and then we're going to activate it. So one of the 4 ways you know how to activate alcohols. PBr3, right? This one does an SN2 reaction built in, just like SOCl2 does. So a secondary alcohol that's wedged with a PBr3 reaction, it's going to end up being dashed with a bromine instead. So the first step that happens here, the oxygen is a nucleophile in all of these. All right, in all these activation alcohols, the oxygen is a nucleophile, adds some phosphorus, kicks out the bromine. That bromine that got kicked out is then going to come back around and kick out the oxygen, right? We've made this a better leaving group, essentially, but we don't make carbocations, right? So HBr makes carbocations, PBr3 doesn't. So that's nice because then we actually get inversion, right? We actually get that inversion. That's how we know it happens. So that's what goes on here. So HBr, HCl, HI, carbocations, PBr3, inversion, SOCl2, inversion, thionyl chloride, that SO2ClR group, that stops. So the middle two, right, stay put. The middle two will actually do inversion. The first one, carbocations, last one, stays put. No, so if you could also put, so even to make it more clear, right, you could have done this. That's great, because that H is always there. And that if that H was dashed here, it became wedged here. So that's great. If you put that in, that's totally fine. Absolutely. All right. So for this one, this Grignard, I had give the starting materials mechanism, including forming the Grignard for each reaction below. Hopefully people saw as you go back here, Grignard adding to epoxide. So this is the Grignard. Where'd it come from? So there's magnesium. So whatever was the carbon here, now is a negative charge. Previously it had to be bonded to the bromine because the magnesium jumps in there. This is like the first radical reaction you learned. So hopefully you did this mechanism where these two things come together, right, and form those 2 new bonds. So this is the starting material. Grignard, how do we make Grignard? So that first radical thing we learned. So now we have an epoxide. Basic conditions, right? Grignard has a negative charge, basic conditions. It's going to add to the less substituted side. Pop that up. That's going to make an O minus. A lot of times you've been seeing this with H plus, but I threw in a little curveball here. I put in a different electrophile. So O minus, it's just going to do an SN2. But the same idea, O minus, just going to add in SN2. That's your final product. So instead of protonating, I had to add and do an SN2.